So we've got a working scientifically example here where we've got a wooden strip that has a load placed on it, and that load is causing the wooden strip to sag a certain height h. So we start off by being told that the load has got a mass of 250 grams, and we're asked to calculate the weight of the load using the formula given. Now the thing to remember here is that the mass here is given as grams. So 250 grams, we need to convert that into kilograms. And remember that there are 1,000 grams in 1 kilogram. And therefore to turn 250 grams into kilograms, we divide it by 1,000, giving us 0.250 kilograms. We then plug that into our equation for weight. So we have 0.250. We multiply it by our value of 10, and that gives us a weight of 2.5 newtons. So here we're given the student's method, and we are asked to identify the independent and dependent variables. So the independent variable is the thing that the student is changing. So if you read this through, it says the student repeats this method for different values of L. So the independent variable is the length. The dependent variable is the one that then depends on the length, so the thing that the student is measuring, and that is the height. Give two control variables, so things that we must keep the same. We keep things the same to ensure that there is only one variable that is affecting the dependent variable, so this helps to make it valid. So two control variables, there's several you can choose from. You can either choose the mass, or you can call it the weight of the load, that's okay. Or you can take the thickness of the wooden strip, because that would affect it. Going back to the load now, depending on where you put it, that would affect it. So the position of the load on the strip. And another thing we need to control about this strip is the material that it is made from. So any two of those. Just how the student could accurately measure the height h. So this is things that you need to do to ensure that the value for h is close to the true reading. That's what accurate means. So you're looking to get the idea that you must be using a ruler. But in order to make this accurate, that ruler must be fixed at the end of the wooden strip. Now, if we want to know that we're actually measuring the correct height h, then it needs to be the 0 on the ruler that is placed at the original height. Now, the other thing we need to think about is the fact that this is a vertical height, so we need to make sure that that ruler is actually measuring vertically. So you can get a point here for talking about some kind of method to make sure that's a vertical measurement. So we can either use a plumb line, or we could use a set square. And the final thing to make sure that you are reading the height accurately off the ruler is to make sure you are measuring at eye level. So any two from there. Now we're asked to fill in the missing value for the height for a length of 80 centimeters. You're given a scale diagram, and you're told that 1 centimeter on the diagram is 10 centimeters in the lab. So you are actually required to take a measurement from this diagram. Now, if you look at the first diagram we were shown, we can see that the height we're looking for is this one here. Okay, so when you take a measurement of that with a ruler, you should get a value of about 3.1 centimeters, although anything between 3 and 3.2 centimeters is okay. You can see from the question that we've got a scale factor here that 1 centimeter is 10 centimeters in the lab. So we take that 3.1, we multiply it by 10, and that gives us a height of 31 centimeters. Okay, then we're asked to plot a graph of the student results. The labels are on the axes for us already, so we just need to make sure that we have used a large enough scale that has equal space intervals. So when doing graphs, make sure you use multiples of 2 or 5. Don't use multiples of 3 or 7 or 6 or funny numbers like that. So 2, 5s, 10s. So you can put your length on the bottom, your height up the side. You get marks here to making sure that you take up at least half of the grid. So make sure your scale is large enough for that, and to make sure that your points are plotted correctly to the nearest half square. Part 3 then asks you to add this line of best fit, and it does say it is a curve of best fit, so it's a smooth curve going through as many of the points as possible. The student concludes that H is directly proportional to L. Evaluate the student's conclusion. So we're now being asked to look at the data we have and say, do we actually think that from what we can see, this is directly proportional? Now, to do this, you have to demonstrate that you understand what we are looking for directly proportional. So for directly proportional, we are looking for a straight line through the origin. Now we can see very clearly from our graph this isn't a straight line, so therefore this is not a direct proportional relationship, and the student is incorrect.